Hello everyone, and welcome to this video titled Algebra Expressions with Exponents. In this video, I'm going to be doing several examples of problems that are taken from the practice at ck12.org in their Algebra 1 text. ck12.org is a site with lots of educational resources that you can practice and use for free. All right. So here's the page, the interactive practice for the topic of algebra expressions with exponents. And I'm going to be going through 5 of these, right? Not all 10. And I would suggest that every time I come across a new example, pause the video and try to work it out yourself. Okay. So this first question here, I'm asked to write x raised to the 5th power as a product. Right, so let me bring up the scratch pad and write out, x to the 5th power. Now, when you see this, expression below another one, there's a variable or a number, and then a number above it, right? That's called a superscript, right? So this is called the base. This is called the exponent. Let me point that out. So this x would be what's called the base of the expression. And then the number up above this superscript is called the exponent. All right. The exponent simply tells you if the exponent is a whole number. The exponent tells you how many factors of the base are in the product. It tells you how many times to multiply the base by itself. So x to the 5th power means multiply x by x by x by x and finally by x, right? So that there are 5 factors of the base, right? X to the 5th power. And that's all we're doing. Writing it as x times x. Now they use the little cross symbol here for times, but this part A would be what they're asking for, right? This as a product, x times x times x times x times x, 5 factors of x. Right, wonderful. Okay, so moving on to the next example. All right, so we're going into now evaluating an expression. All right, finding the value of an expression when I plug in a certain value for a variable. So here we're asked to evaluate the variable expression using the given value. The variable expression is a to the 3rd power, or a cubed, and then afterwards plus 14, when the value of a is 6. All right. So the expression given is, a to the 3rd plus 14, and the value of a equals 6. So I'm going to replace a in the variable expression with 6. And I would recommend that when you make a replacement or a substitution that you put parentheses around it. Get in that habit. So this is, 6 is replacing a. That's being raised, to the 3rd power. And then after that, we are, adding 14. Now, remember your order of operations. You do, exponents before multiplication and division, and then before addition and subtraction. And we're going from left to right. So the first thing I'm going to do is this 6 to the 3rd power. Now remember, 6 to the 3rd power means 6 times 6 times 6. All right, so you could write it this way if you wished. And then, of course, I still have the plus 14 after. And then we'll do multiplication from left to right. 6 times 6 is 36. So this would be 36 times 6. And then still have this plus 14 after. And I still have multiplication to do. 36 times 6. Now, again, you can break up 36 to 30 and 6, and do 6 times 30 is 180. 6 times 6 is 36, and then you add those up. 180 and 36 is 216. All right, so the product of 36 and 6, or 6 to the third power, is 216. And then we're going to add 14. The only operation left is addition now. And 216 plus 14 would be 230. This is what they're asking us to find, right? Find the single value of the expression after replacing the variable a with 6. And it would be a value of 230. So back on the choices, 230 was choice A. Let's check it out. And wonderful. All right. So the next example. So another expression, well, this is actually an equation involving variables x, y, and z. And we're asked to, substitute 2 for y, 2 for x, and then determine the value of z. All right, so z, make sure I can see it here. So z, right, is y to the third power y cubed minus x to the third power, right, x cubed. But we're replacing y with 2, so that's 2 to the third power, and then also x with 2, right, so 2 to the third power. Now you might be able to say, hey, 2 to the third power minus 2 to the third power, it's an expression minus itself, right? You got something minus itself, and anything minus itself, should be 0. But I'm actually going to raise 2 to the third power here. All right, so remember what 2 to the third power means, right? This is 2 times 2 times 2, right? You got the base times itself 3 times. And then same thing, then you got minus, and then same thing here, right? 2 times 2 times 2. Now, I hope you know that, 2 times 2 is 4, and then 4 times 2 would be 8, right? So 2 to the third power would be 8. So this is 8 minus 8. And, I said earlier, that's going to be 0, right? So there's your z, right? I had z equals on the left side over here all the time. So z equals, 0, and the value of x is 2, and the value of y is 2 in this particular expression. And I'm just, there's no multiple choice here. I'm actually entering the number 0 and checking. Great. All right, so moving on. Example 4. All right, so this is another expression with, exponents. And we have, b to the fourth power divided by or over b to the second power. And we're replacing b with the number 6. All right, so I'll write that expression. We have b to the fourth power divided by b to the second power. Now we can, I'm sure we'll come across a part of this book later where we have properties of exponents. So I'm not going to get into that just yet, but when you divide two expressions that have the same base, the numerator has a base of b, exponent 4, and the denominator has also a base of b and an exponent of 2. So they both have the same base. When you see that, you'll be able to simplify the expression. Let me show you. So the numerator, right, b to the fourth means, b times b times b times b, right? B to the fourth power. And the denominator is b to the second power, right? So that's just b times b, right? And then you got, change of color here. There are factors of b in the numerator and factors of b in the denominator. When a numerator and denominator have common factors, they can simplify, right? You can cancel, like b here cancels with one of the b's here. Those would become 1. Anything divided by itself, anything over itself would be 1. And then there's another factor of b in the numerator that would cancel with a factor of b in the denominator. And so what I'm left with now is in the numerator, we have b times b, right? That's just b to the second. And then the denominator, everything that got crossed, everything that I put a red cross through would become 1. So the denominator would just be 1 times 1, which is 1. And, dividing by 1, I mean, you could write it. There's nothing wrong with that. But anything divided by 1 is itself. So b squared divided by 1 is just, b squared. So this expression we started with, b to the fourth divided by b squared, simplifies to just the same thing as b squared. And now I'll pop in, the value we were given for b, right? The value of b is 6. So I'm going to replace b with 6. So from here, we're going to substitute, 6 for b. I know my 6 and my b's look pretty similar, but so this just ends up being, 6 to the second power, which is, 6 times 6, or 36, right? So that's the value of that expression after simplifying, 36. So I'll enter that, right? 36. Check it out. Wonderful. Okay, and so I'm going to do one more example here, right? I'm not going to go through to the mastery or all 10 of them. I'll leave you to do that. And the nice thing about these CK12 practices as well is that even if you finish 10 out of 10, finish 10 questions correctly, you can continue to practice after that as much as you wish with other similar problems. All right, so the final example I'm going to do in this video is another one involving, exponents. It says evaluate the following expression when x is 11. That's your answer as a fraction, a divided by b, a over b. All right, so we have the quantity, right? This fraction, x over 6, x divided by 6 in parentheses here. And this is being raised to the second power. So remember what that means, right? So we have, x divided by 6 to the second power. Again, remember raising some, the base is what is underneath the exponent. So the base here is this x divided by 6. So that is getting raised to the second power. That's being multiplied by itself twice. X over 6 times x over 6. And then when you're multiplying fractions, you just multiply the numerators. So the two numerators are x times x. So that's x to the second, right? X squared. And the denominator is 6 times 6, right? The denominators are 6 times 6, and that's 36, right? 6 squared is 36. And this is what they were asking for, right? Actually square the expression, actually raise the expression to the second power, and, write it as a single fraction. Right? All right, so entering the answer here, so I'm going to put in my numerator, in parentheses, x to the second power with the caret. The caret is above the 6 number, right? X squared in the numerator, and then slash, right? Divided by, and then we have 6 squared, right? 36 in the denominator. Oh, I'm sorry. We were asked to plug in a value. My apologies. Right, we were asked to find the value of this expression when x was 11. All right, so now I'll take this thing in the box here and put in 11 for x, right? So we're going to take this expression here, replace x with 11. And so now the numerator is, 11 to the second power, divided by 36, right? 6 squared was 36. And so the numerator is 11 times 11, right? Divided by, 6 times 6 was 36. And 11 times 11 is 121 divided by 36. All right, and this is what they want. Right? This is the actual thing I should be entering in the answer, not, because they had me plug in the value of 11. Also, right, 121 was 11 times 11. 36 is 6 times 6, and each of the 6's is 2 times 3. So the numerator has factors of 11, and the denominator would have factors of 2 and factors of 3 in it. So there are no common factors. There's nothing to cancel to simplify this fraction. So this 121 divided by 36, or 121 36ths, is the simplified answer there. That's the one I'm going to enter. So back here, 121 numerator divided by 36 denominator, and check it. Wonderful. Okay, so as I mentioned earlier, right, I'm only going to be doing the 5 examples. I'm hoping that seeing the first 5 here help you out when you see other ones, just evaluating expressions that involve exponents, right? And the key takeaway here is to remember that if your exponent is a whole number, 1, 2, 3, 4, 5, and so on, that just tells you how many factors you're going to have of the base in the product, right? It's how many times do I multiply that base by itself? And then, of course, you multiplication. All right, so there you go. 5 examples, algebra expressions with exponents. And thank you very much for watching.